All right, so these notes are just going to be specific examples for multiplying, which is what you are learning in your chapter 4 sections. So the first thing we're going to talk about is just an array. All right, and an array is really just a visual of multiplication. So when we talk about something like maybe an A times B, you know what that means? It means A equal groups with B objects. In each group. All right, so for example, if we do something like 2 times 3, that's going to be 2 equal groups with 3 objects in each group. So if we want to show that visually, we can do that with an array. So let's do a 2 by 3, 2 equal groups with 3 objects in each group. So we're going to have 3 objects in each group, and we're going to have 2 of those that are equal. So that's an array. That's okay. Now I could also write the other way, where I could do 3 equal groups with 2 objects, right? So if we write this as a 2 by 3, then we could also say that we have 2 groups with 3 objects. So this then can be a 3 by 2. So just a couple different ways to show a visual of multiplication, pretty basic with these arrays. Okay. Sometimes we use areas, right, to do length times width, and we can show the different objects in that as well. So this is where you would see then the commutative property. So that's an example of using commutative property. An array is 2 times 3 equals 3 times 2. Okay. So let's talk a little bit. I'm going to draw a line here so you don't get confused. Let's talk a little bit maybe of the associative property. And this is commutative property of multiplication specifically. Okay. So if we talk about the associative property of multiplication, okay, so we're going to talk about, remember, this is using the A times B times C equals A times B times C. Okay, something like that. There's multiple ways to write the associative property, but let's say we have something like 7 times 600. So how can we work with students to break that down? We can write that as 7, maybe break down the 600 times 6 times 100. We could also have written that as 7 times 6 times 100. So depending, 7 times 600 then would be 4,200. 42 times 100 would be 4,200. All right, so just a different way that we can use the associative property of multiplication. I'm not going to go into a lot of depth with that. However, a lot of times when we use the associative property, because we have 3 different terms, if we have an A, a B, and a C, then that makes our visuals more 3-dimensional. So just, I'm not going to draw this out, but there's a pretty good picture on page 158 in your textbook. It's figure, what figure is it? 417, I believe. And that just gives a good picture of using the distributive property with a visual, but it's more 3-dimensional. So I would not ask you to draw that out. What I would expect for you to be able to show me is just something like this, you know, in terms of just showing how the associative property works for multiplication. Okay. All right, so let's move on. We've got quite a few things to talk about on here. So first of all, when we talk about standard algorithm, there's always lots of questions on standard algorithm on when that should be taught. Some people think it should be in 4th grade. Some people think it should be started in 3rd grade. And so right now I believe it's 4th grade in the standards. But anyway, so a standard algorithm is just really doing, it's very procedural, right? So if I want to take something like 45 times 6. So 5 times 6, I'm sure you kind of remember how to do this. 5 times 6 is 30. So we carry our tens over. 6 times 4 is 24 plus 3 is 27. So that's just the very procedural way, step by step, of solving a multiplication problem. And you know what? Some students do really well with this. You might do really well with this, and that's great. But we also owe it to our students to be sure that we give them options to learn in different ways to multiply, so they can choose what works best for their learning style. We don't want to, put everybody in the same boat. We wouldn't want that for ourselves. So some other ways that we can teach multiplication aside from the standard algorithm is another way that's called is partial products. So this right here is standard algorithm. Okay, so partial products is just kind of breaking products, not production. Okay, partial products. It's just kind of breaking down your numbers into the base 10 system. So this deals more with base 10. It is more steps. So I don't know that that's always great, but I think it's an easier way to explain maybe what you're doing over here in the standard algorithm. But it also, this is in more detail. So it does take more time, but it also validates that the standard algorithm works. So I can break this down and show that I get the same answer that I do here. So this validates the standard algorithm. Okay, just another way to teach students. So if we take the same problem, let's do 45 times 6. Need a little bit more room here. So we recognize here that, oops, I want to write it this way. Okay, so here we're going to multiply 5 times 6. So 5 times 6 is 30. But what we kind of want to do is explain, well, what is that actually? What did I just do? Well, I took 6 ones, right? And I multiplied it times 5 ones. So 6. Now you can do this a couple different ways. I'm just going to do it this way. Oops. 6 ones times 5 ones. Okay. All right. So next, what am I going to do? Well, now I'm going to take 6 ones times 4 tens. So that's 6 times 40. So the multiplication is easier here because it's always in base 10. So you're multiplying by ones, tens, hundreds, which students are usually more familiar with. All right. So then we just add down. We still have to add down. Sometimes we might have to borrow and carry 270 to get the same answer. Okay, let's try another one. So let's do the standard algorithm for 186 times, let's just do times 4. Okay, so 24, so we carry our tens, 32, 34, so we carry our hundreds, 744. All right, now, again, some students do really well with this. Some students get confused with the multiplying and the carrying and the place value when you have to put a 0 as a place value, right? So let's take a look at that over here if we do partial products. So 186. Okay, so the first thing we're going to do, and we write it out what we do each time. So just put a drawn arrow there. So here we have 4 ones times 6 ones. So that's 24. All right, then we want to take 4 ones. I'll just draw an arrow so you see what I'm doing on each step, times 8 tens. So that's 4 times 80. All right, then we want to take 4 ones. Sure, I don't go off the screen here. I'm known for that. All right, so 4 ones times 100. So 4 times 100. And then we add down. Okay, so again, this is a little bit more explanation. It's more detail, takes a little bit more time because there's more steps, but it's all in base 10, which is a little bit easier for students to understand because they work with base 10 so often, and that's how they learn the place value. So just something to think about with that. All right, so let's go on. Let's go ahead and talk about the distributive property. So distributive property is pretty big and it has different parts to it. So I'm going to show you different parts. So, all right, so for the distributive property, the first thing I wanted to talk about with this is, and again, this is a multiplication. These are all a multiplication. Okay. If I have something like A times B plus C, What I do here is I distribute this A through and I'm multiplying it times both terms in the parenthesis. Okay, that's the distributive property. So we're going to do quite a few things with this. The first thing I'm going to do is just show you a proof of the distributive property. Sometimes depending on the grade level, this might be a middle school grade level even, but just showing them where it comes from, I think it just gives them a little more understanding and a little more foundation about just memorizing, oh, it's a distributive property, so I multiply it through. All right, so a proof can do that. You don't want them to be too advanced, but just maybe something that you could talk through with students. Again, it has to be an appropriate grade level where your students are able to comprehend what you're saying with this. All right, so if I just start with something like this, okay, and we're talking about what this really is this is a multiplier, and this is a repeated addition. That's what the distributive property is. This is your multiplier, and you're repeating it this many times. So a repeated addition, I'll write it in here, would be written, A plus B plus A plus B plus blah, 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 all the way, depending on how many, whatever your multiplier is, however many that you need here. So that's really what distributive property is. It's just repeated addition. So when I get this, then I would also then say, okay, well, then I can add all my A's together, depending on how many I have. And then I would add all my B's together. Again, depending on the number. And that then is where we're going to get the repeated addition of is going to be the number of A's plus the number of B's. So let me show you that. Let's start with before we do a complete example. Let's say we have 4 times A plus B. So what that is saying, again, this is our multiplier right here. So make note that N is the multiplier. So I'm going to take 4 of those. So A plus B plus A plus B 4 times. Now that's the repeated addition. And what this is saying, all right, I'm going to take A plus A plus A plus A plus 4 B's. So we're adding our A's together and we're adding our B's together. So what this equal is, how many A's do I have? Well, I have 4 A's plus I have 4 B's. Okay, and that's the proof for the distributive property. Now let me show that to you with just a regular example. Let's say we have 3 times, I don't know, let's just do 2 plus 4. So we're going to do this 3 times. So 2 plus 4, sure it can go off. So we're going to add 3 2's, plus we're going to add 4 4's. So 3 2's plus. And then you could continue to finish your answer here, but we're just kind of showing the proof of the distributive property. So repeated addition, okay, with your multiplier of how many of each. And that's not too bad. All right. I wish that you could ask questions and respond to me. So we're going to keep going here. All right, so speaking of the distributive property, one method of distributing is using the box method. And these are ones that you're going to have to show me that you can do. All right, so a box method. So let's just take 764 times 58, 764 times 58. So what we're going to do is we're going to put that into a box. It doesn't have to look perfect because I guarantee you mine won't. There we go. So we're going to take 700, okay, plus 60 plus 4. And then over here, we're going to have 50 plus 8. So again, it's breaking it down into the base 10s, right? So we'll go ahead and split these apart. Got a big space for the 4s. All right, so here we'll multiply 50 times 700, 50 times 60, and then 50 times 4. So you can see the multiplier here is 50. And then here we're going to multiply 8 times 700, 8 times 60, and 8 times 4. So when we write this out, you can see that if I use the multiplier here, it's going to be 50 times 700 plus 60 plus 4, because 50 is the multiplier here. And then plus the multiplier here then is 8. So 8 times 760 plus 4. All right, so what we've done here is we've already broken this apart so that you can see. So I'm just going to write that out here. So this is 50 times 700 plus 50 times 60, which is all written here. 50 times 4 plus 8 times 700 plus 8 times 60. Oops, I better write it the right way. See, try to do it too fast. So 8 times 700 plus 8 times 60 plus 8 times 4. And then we can multiply and add all those up. So here we have 35,000 plus 3,000 plus 200 plus 8 times 700, 5,600 plus 480 plus 32. So then if I add all these up, that's putting it into the standard algorithm. So I'm going to put it up here so I don't waste all my paper. So 35,000 plus 3,000 plus 200 plus 5,600 plus 480 and plus 32. So if we're adding all of those together, we're going to come up with 44,312. All right. So here you could be using your standard algorithm and you would be carrying on each of these. But, and so here with these, this validates the standard algorithm, meaning I can distribute in a different visual way, but it's validating what you would, that you would get the same answer as a standard algorithm. Okay. All right. So that's the box method. It's a little bit nicer if you have smaller numbers, but that's not too bad. All right, so here I should probably put equals 44,312 as well. All right, so that's one method of distributing. Okay, so a second method of distributing is the FOIL, which some of you might remember from your days in high school. All right, so FOIL. So when we FOIL, that's talking about, this is going to be the first. F stands for the first. This is the outside, inside, and last. So that's how you, that's the order in which you distribute. All right, but it's just another form of distributing. So if we have A plus B times C plus D, now I have to tell you, this only works if you use what are called binomials, which are just two terms here. So if I had A plus B plus C plus D plus E plus F, that doesn't work for FOIL. You can distribute, you can do the box method, but not foiling. FOIL only works if you have two terms in each of these parentheses. All right. So let's go ahead and use the FOIL. So my first here would be A times C. Okay. And then the outside is going to be the outside A times D, the two that fall on the outside. And then the inside are the two that are on the inside here. So B plus B times C. And then lastly, as L is the last, and that would be B times D. So notice they're still being A's being distributed here as a multiplier, and B's being distributed here also as a multiplier. Okay. So let's take, for example, 5 plus 2 times 5 plus 3. So if we multiply the first, we're going to have 5 times 5 plus the outside 5 times 3 plus the inside 2 times 5 and plus the last 2 times 3. So then we have a pretty simple. Okay, if we add all those up together, that equals 56. Okay. So there's FOIL. Now let's look at FOIL as a visual. So just another way to show a visual with this. Just want to start with some kind of a square here. So we have 5 plus 2. So up here we have 5 and 2. And then over here, we're going to have 5 and 3. And it doesn't matter if I put 5 and 3 here. Oops, sorry. No. It doesn't matter if I put 5 and 3 here or 5 and 2 here. They can be in any order. All right. So we're going to go ahead and we're going to have 5. And then mine probably isn't going to look very good, you guys, but we want to have 5. I'm breaking this into columns. 1, 2, 3, 4, 5. Okay. So this one I'm going to kind of darken because that's 5. And then we have 2 over here. So make this look a little better. And so we have 2 here. 5 and 2. All right. So now let's do our 5 and 3 over here. So 1, 2, 4, 5, and they're not very even. Okay. And then down here we have 3 that fall. 2, 3. All right. So there's a bit of a visual that you can see here. So students can see, all right, so 5 times 5. But what else they can see with this is they could just go through and count them individually if they needed to do that. And that's why that visual is helpful for them. And then we have 5 times 2. Okay, 3 times 5. And then 3 times 2. So they can count them and recognize the value, and also that turns out to be 56. Right, so just a couple different ways to look at the distributive property. Now, let's try doing this. I'm going to actually try doing on the same page. This is more maybe of a maybe 7th grade, if they're in starting like a pre-algebra. So let's just do an example here of x plus 3 times x plus 4. Just a little bit higher level, but it's still using the same. I'm going to use this. We're going to use what's called kind of like a box method, only we don't break it up into individual pieces because we don't know what x is. So there's an unknown in there. So again, let's just go ahead and start with the probably square-ish in my case. And so here we're going to have x plus 3. And again, this could go on either side. It doesn't matter. And then we have x plus 4. So now we can multiply x times x is x squared. X times 3 is 3x. 4 times x is 4x. And 4 times 3 is 12. And then we can just draw these vertical lines. You can go down or you can go up. Since I'm out of room at the bottom here, I'm going to go ahead and go up. So we draw this with straight line that goes through here. That's our x squared. And then we go through here. Notice these are the like terms. So 4x plus 3x, that's going to give us 7x. And then we have 1 here, which is 12. So x squared plus 7x plus 12. Pretty simple, not necessarily simple, but an easier way maybe to multiply this. Although you could also go ahead and go up here and use the FOIL method that we learned as well. So either one, just a different idea, a little bit higher level. All right, so let's do one more method of distributing. And this one is called the break apart method. And so what this does is, again, it just breaks numbers down into, we try and break them down as much as possible into base 10, just because it's easier to multiply by a 10 or 100 or even a 50 than it is by a 52. So that's kind of how this helps students. It's an easier way to break numbers down. So let's say we have, again, we kind of make it as a visual here. So we have 16 times 8. So one of these has to be the multiplier, and it really doesn't matter which one. Either one will work. I usually take the smaller number as the multiplier, but that's entirely up to you. And then what you have to do then is you have to break the 16 down. Okay, and you have to figure out how you want to break that down. Well, I normally would say, let's break it down so it has a 10. So maybe we'll break 16 down to 10 and 6. And then we have this multiplier that we have to multiply both parts by. All right. So the distributor property just comes in right here. So you see the distributor property. So our multiplier is 8. So we're going to multiply 8 and then 10 plus 6. That's the distributive property. Okay, now to solve this though, let's just come down here. Come on down here. And we just take 10 times 8 is 80. 4 times 6, because this will leave you in single digits, which students, if they have their multiplication tables down, they can do that. And then add those together. Oops, but do it correctly. Yeah, I think I did. Actually, 128. There we go. All right. So let's try another one. So let's do something maybe I should make these numbers up because I can't add them together at the end. How about 52 times 4? So we want to find an easier number to break this down into. So maybe let's have 4 be our multiplier. Should we maybe do 50 and 2? Okay. And then we have our multiplier. So the distributive property is shown right here. Multiplier is 4. 50 plus 2. And then from there, that's our distributive property. Okay, so bring this down so we can get our solution right down here. So 50 times 4 is 200. And then 2 times 4 is 8, which is 208. Okay. All right, that's the break apart. Just another way to show the distributive property. Okay. All right, so the last thing I have to show you is multiplying using Chinese multiplication sticks. So I have to tell you though, these Japanese also have multiple Japanese multiplication sticks, and it's the same thing. So I guess it could be, I've always just done the Chinese because I haven't studied the Japanese as much, but the Japanese are, I think, pretty much the exact same thing for all the examples that I've seen with the Japanese. But this is just kind of a fun little hands-on way to teach students. You know, you can have them draw it on paper. You might be able to have them do sticks. I wouldn't use like pickup sticks because they have the pointy edges. They'll be gouging each other. But if you just have like sticks, you could try using the sticks, which is a nice manipulative to try and do, but also just having them draw out. So you don't necessarily have the model, but you can visually have them just draw it out on paper as well. So let's look at a problem like this. So 32 times 24. So this is when we're going to draw vertical lines, and this is where we're going to have horizontal. So our vertical, we want to do our tens place and then separate a little bit for the ones place. So they need to be separated. So first thing we're going to do is 32. So let's just do, okay, so that stands for my 30. Those are the 3 tens. And then leave some space because you can see it better if you have more space. And then these 2 are my 2 ones. Okay, so now let's do 24. So 24 is, we're going to start up here and we're going to do our 10. So we have 2. And we're going to leave some space. You can make these longer if you need to. And then we're going to have 4 down here. Now you just have to be sure that they go all the way through the lines. Okay, so they go all the way through. All right, so this right here, these are your ones that fall right here. So we're going to look at where these lines cross each other. Okay, so how many places do they cross each other in this area? Those are your ones. So that's 8 ones because it crosses in 8 different places here. Okay, now this area and this area here, this area, these are your tens place. So how many tens will we find? We find that how many tens there are by wherever they cross. So there's 4. And then down here, all of these where they cross. So 4, 12, 13, 14, 15, we have 16 tens. And then up here, these are the hundreds. So here, wherever they cross, so we have 6 hundreds. So now that leaves us with 600, right? 6 hundreds, 16 tens, and 8 ones. this would equal 768. It's really kind of fun. My students in the past have really enjoyed doing this, just because it's something kind of different. Now, if you had these sticks laying out, I mean, I don't know, because they move, so it might be kind of difficult. It just kind of depends. Maybe with straws, I don't know. I did it once with skewers, but I did it with older kids, and it worked out great. But I'm not sure with young kids. We might just want them to draw it out. Okay. All right. So let's do one more of those. I'm going to do one that has 100 in it. I think I have. Let's do. Let's see. Let's do 125 times. Let's make it a 31. 125 times 31. All right. So here now, this means we're going to have three different places. We have 100. So we'll start over here. We have our 100. And then we have 2 10s. So over here, we're going to have our 2 10s. Again, it doesn't matter how much space, but the farther apart it is, the easier it is to see, I believe. So then we have 5 1s. That's just my opinion. So you can, depends on how much paper you want to use. All right, so there's our 5 1s. Okay, they don't have to be perfect. So then now let's do our 31. So we have 3 10s. So we always just start at the top. There's our 3 10s. Okay, and then we have just 1 1 down here. All right, so 125 and 31. So let's look at our 1. So here's our 1s right here. So 1, 2, 3, 4, 5. They cross in 5 places. So we have 5 1s. All right, now this is all of our 10s here. So we have 10s here and here. So you just got to be able to see that. You get more comfortable the more you do that you see that. So here's 2. So 3, 15, 16, 17. So we have 17 10s. Okay. And then here now we have this, which is going to be our hundreds. So here's 1. So 6, 7. So we have 7 hundreds. And then lastly, we have this, which in this case are our thousands. So we have 3 thousands. So let's take all those. So 3,000 plus 700 plus 17 10s would be 170 plus 5 1s. 3,875. So just another kind of quirky, fun, way to look at multiplying using a different method. And I believe you have a video that shows, some different, like a Russian method, and they're kind of interesting to see the diversity and how different countries multiply and what they do with their students. So, anything that we can do to give our students another opportunity to see something in a different way, whether they end up doing that way or not, right? It just gives them new ideas, new thought process, and something different to try. So, all right. Well, thanks, you guys. I hope you have a fantastic day. And so there's your chapter 4 multiplication.